Well, yep, let's start. I'm Anton, that is Natasha, and we want to present you our small project on action in Russian. Well, let's discuss why this problem is, why we decided to study this problem, this topic. Well, firstly, humor is a really important part of human speech, and it's hard to imagine communication without humor, and that's why we study. We suppose that understanding of humor provides an opportunity to improve the communication between human and computer. And another reason is that this topic is really well studied in English, but in Russian there's lack of such studies. And we tried to apply some knowledge from English studies to Russian jokes. Well, let's discuss some of solutions. The first one is Making Computer Laugh by Mikhail Sinister-Poraba, which tried to analyze humor in three aspects. It's alliteration, economy, and adult slang. The other paper was called Humor Recognition and Anchor Extraction by Young, which tried to analyze humor in four quite similar but different aspects like ambiguity, incongruity effect, interpersonal effect, and phonetic style. And the last one is a set of reports from a kind of competition in humor detection, which is called SAMWAL. We also tried to look at these reports. So let's define our problem, given text in Russian, and we try to understand whether it's funny or not. What we did, in fact, we collected a data set of funny and non-funny texts in Russian. Then we tried to analyze them. We tried to extract some features from those data sets depending on some known studies and on our vision of why a text may be humorous. Then we just conducted some experiments and evaluated the performance of different feature subsets. So, not data sets. Funny texts were separated into two parts. The huge one is an existing data set of one-liners that are just short jokes collected from Russian social network. And the other data set was collected manually by our team. It consists of around 200 puns. Actually, it was really hard to collect this data set because there are no too many jokes based on wordplay in Russian. It was really hard to find them. And currently this data set is available for experiments. You can find it. And another data set of non-funny texts consists of three types of texts that use headlines, proverbs, and different sentences from non-humorous books. Well, then we tried to extract features, and we combined them into the following, we combined similar features into the following groups. Let's talk about them. The first one is bag of words. In fact, it just treats text as a vector of words. Yes, it just treats text as a set of words and uses each word as a separate feature. In fact, for each sentence, then we know whether it contains some word or not. The hypothesis behind this is that some words are more common for funny texts and the other are more common for non-funny. Then the other group is sentence-to-vec. We tried to represent the whole sentence as a vector based on word-to-vec representation of each word. And you could also see here how we calculated it, depending on inverse document frequency, which we got from Corpora. Then another group is structural features, which are based on some structural traits of a sentence, like average word length, then question, exclamations, and so on. Another group is lexical features, which try to find some lexical traits. For example, word frequency. And here you could also see an example where the phrase in a queue may be represented in different ways. Yeah. Then the last two groups, the first one of them is RoadNet, which uses RoadNet thesaurus to evaluate different features. Actually, it tries to extract such features like synonymy, antonymy, and ambiguity. And the last group is Word2Vec, which is also, I think, well known. It just tries to use word vector representation of each word to calculate, to measure meaning distance between pairs of words, and tries to extract the sense of the whole sentence somehow. And, well,
Hi everyone. Okay, let me briefly describe what data sets we had. So we had the two major data sets, like major data sets. So we combined one-liners and non-funny texts, which are news headlines and books and proverbs, and we mixed them together in equal proportion. We split them into the 80-20 ratio for the test and training data set, and we separated all the one-liners into a separate data set. And then we ran the and then we computed the feature vectors and ran the SVM algorithm on these features. We used different parameters for the SVM algorithm. That is, we used different kernels, and we also used different subsets of features and ran it multiple times with different subsets. Okay, let's look at the results. First of all, we ran the algorithm on each feature set. Okay, good. Okay, sorry. Okay, and yeah, so we tried to run them separately. The best performers were bag of words and sentence-to-vec feature sets. And when we ran them using subsets of multiple feature sets, the bag of words and the sentence-to-vec feature sets performed very well, just the two of them. And when we added some other feature sets, we slightly increased the performance. And as you can notice, we got around 69% recall on the PAM dataset. Okay, so once we get the results, we want to analyze what could be improved, what went wrong, what we could do to do better. And we did manual analysis of the jokes or non-funny texts which were misclassified. The first unfortunate reason for misclassification was, which we figured out, is that most of the misclassified funny jokes were not funny. The problem with that is that the dataset we had, the one-liner dataset, we took it from another research paper, so
there were little we could do with it. It was quite hard to try to clear it. It was hard to go through it manually because it contained 60,000 jokes. So we just had to live with it. The next problem was that sometimes sometimes the jokes which were, so let's look at this joke. Dan Beetle brought his wife Raffaello as a birthday present, and just in case you're unaware of what is Raffaello, it's a candy, it's a ball-shaped candy, which looks like this, and it looks like a ball of mug, which Dan Beetle can bring to his wife. And this joke requires extra knowledge to comprehend. You have to know what Raffaello is. It can be inferred just from the word Raffaello. So this is a problem. You have to use some extra knowledge engine. And the next problem we encountered is that, which applies especially to the PAN dataset, is that the jokes which contain puns are very short, and the words surrounding this joke they're little words, so it's hard to infer extra meanings, and this can be a problem as well. Okay, so why we got good results, on the other hand. So for the bag of words, Anton, would you like to?
Well, okay, as for bucket plots, we try to analyze why this group of features behaved in such a way. Well, we suppose that jokes usually use some simple vocabulary. And it's not so common for literature and perhaps on news. And if we remember what is back words, that it just treats text as a set of words, then I think it's understandable why it behaved in such a way, why we get such high results. Well, the other group is WordVec, which got the worst results. And it's also understandable because this group of features contained only 2 features. And I suppose that they just couldn't extract the whole sense of the sentence just using meaning distance between words. And another group is RoadNet. Well, some studies like human ranker extraction by Young et al. Used similar features in their project, and in their project, in their study, these features got really high results. But in our case, we analyzed our data sets and we found that most jokes just didn't contain any ambiguous words at all. And that's a kind of a problem. So in conclusion?
Yeah, so to sum up, what we did is we collected the PAN data set, we collected the non-funny text examples such as news headlines, books, and proverbs. We developed a set of features which characterize the text and run the algorithm and get pretty good results for the classification.
And last, some of our plans for further research. Well, we just want to collect now relevant data set of puns, as well as more representative data set of jokes and some non-funny texts, as we found that our data sets are rather poor. And then we also try to analyze how separate features behave on our texts, as currently we try to analyze whole groups. And at last, I think it's possible to obtain, to apply obtained results to another problem, which is image generation, but it's possible. I think that's all. So you may contact us. You can find our PAN data set for your experiments if you want. I think that's all. Any questions?
Also get Rafaela candies after the session. There are plenty of them.
Thanks for the great talk. Actually, it seems that the results are extremely good, and it seems, as for me, it seems that the problem is that lexicons in the puns and or in the jokes and in your data sets, news, books, are completely different, and you show that bag of words is extremely good and provides good results, and it's something like not to talk about that. Maybe it is more fair to compare something like Stiglitz-Smith-Cheburashka with Stiglitz-Smith-Müller. Okay, and where is the joke and where is not, please? Cheburashka means again, Cheburashka means Stiglitz, please. In such case, yeah, you will be really detecting jokes and non-jokes. But now you're comparing Stiglitz with Cheburashka with a bridge was built. That's strange. What do you think about that?
Okay, thank you for making the point. Yes, it is true that these data sets are, you can actually look at these data sets and see they're quite different. So it might be more fair to rerun the algorithms with better data set.
Actually, as I know, Pavel Bruslavsky currently works on another project, and in that project they try to collect different texts from Twitter. Well, there are lots of non-humorous short texts, and I think it's possible to use this dataset too to run our classifier and to look at how it.
Okay,
But yeah, we understand that our datasets were, in some cases, rather poor.
Thank you.
Coming back to your example with Rafael, do you see any ways how to improve results of your work in such cases like Rafael case? Do you see the way how to, what could be done, what other things could be done to detect such cases in this work?
Well, I think it's it could be possible to. Well, the problem is that that computer just don't know what Rafaela is. If it known that Rafaela is, well, maybe it's just a problem that maybe this problem could be solved just if it was possible to store some sense for different.
When you store, okay, so let's take as an example. You make a dictionary where you store some meanings of some words like Rafael, etc. But you should apply somehow this meaning to your existing word, right? How do you see this could be done?
Just to change somehow this well, possible solution just to change this word to the sentence or something like this that represents the sense of this word. For example, we use RoadNet features which try to measure sense distance between different words, and here we know that. Well, yeah, I think it's better to look at Russian translation of this joke. Here, word "прикатил" just could be matched with ball-shaped candy.
So it means, so it means the dictionary would contain kind of two words, right? So first Rafael and another word which is similar to Rafael but well known for the algorithm.
Well, I think it's just better to use existing definitions of such words. For example, using Wikipedia or something like that. Just.
Any more questions?
Thank you.
Please.
My question is, can you find jokes in literature? In books of literature?
Uh,
Use them as non-funny words?
We try to collect sentences from non-humorous literature. I mean, we selected some authors that usually don't have. Huh? Well, there's a small chance that this dataset contains jokes, but I believe that those books that we choose, I believe that they don't contain jokes.
More questions? Okay, the last one, please.
Maybe I lost it in your presentation, maybe you tell about it, but do you try to find punchlines? I mean, there is some point in the jokes when the meaning of whole thing is changed, and as you said, there is a new meanings of words that used, and we don't think that they could be used in previous sentence. So, do you try to find this exact point of punchlines in your examples? So, if you find these punchlines, you would try half negative mining, switching punchlines for different examples of jokes, and there will be no jokes if you just switch punchlines for different jokes. So, like during Beatles wrote his wife, threatened as a verse, it won't be a joke now. But it has the same words as their other jokes. So you won't be, how does it work? Переучаться. Sorry. Overfit, yeah. So you won't be overfitting your algorithms. Maybe.
Is it overfit or not? Yes or not?
We use cross-validation well, we use cross-validation to test whether there's any overfit, but it's possible.